Thank you. So thanks for for giving me the stage on this topic. So my name is Antony Nardozza, as written here. I joined Spairliners now 7 years ago. I was working 6 years for Airbus in before. Now I'm taking the place of material planning manager. So I'm in charge of the entire inventory for this company to decide on the investment and divestment. If we look in the aviation, especially in the spare part business, the specificity of our activity is that we are working in a closed loop. The customer demands are not reducing our stocks. Every time you made an invest, you keep with this asset in your book, in your inventory, and you have to work with it. The tricky part is an aircraft is only created value while it's in the air. So our goal is to avoid to have an aircraft on ground. We have, and it's mandatory to deliver parts to the customer. We are exclusive providers with our contracts, and this forces us to give an outstanding service to our customers, which is not always very common in the aviation business. With this loop, we, as you can see, are facing different lead times, a lot of them. The repair shops are giving us a lot of variation in terms of resupply. The customer are as well having different schedule to fit the parts we deliver them. There are different expectations in terms of part deliveries. And so all this loop is somewhere our challenge. How can we put in place the correct inventory to enter the customers and not to spend too much money on useless parts? So Spairliners, we are a joint venture from Lufthansa Technik and Air France Industry. We are located with the headquarters in Germany, having storage location mainly in Europe, but as well in Singapore and anytime soon in Miami, creating this place for the end of the year. In a few numbers, our inventory is around $200 million of aircraft parts. We do have to deliver this part in time to the customer as per our contract, between 95 and 99% on time. But as we are exclusive providers, we do have to deliver always the part they are needed. It's not an excuse. And this is covering over 1 billion yearly component flight hours. So this is all the risk we have to have a demand from a customer. Being a small part of Air France and Lufthansa, we support 200 aircraft. They do support 3,300 aircraft. We are located and focused on a niche market, which is the A380 from Airbus and the E-Jet family from Embraer. We are really used as somewhere a laboratory, a place where they can test new technologies, a new way of working, new approaches to the problematics they are as well facing. And in this purpose, we pioneer the probabilistic forecasting at scale for the aviation. It's something which is a bit more common in finance or insurance business, but not at all in the aviation, which is really, I would say, a handicraft environment. So our journey through this concept, we started with, I heard earlier, a solution which is very rigid, it costs a lot of money, and we have a bit the same experience. We spend a lot of money with a market-leading solution, which was definitely too rigid for us. We could not fit in this frame they were offering us. The processes has to match their solution, and not the other way around. And we realized very quickly that we received very insignificant recommendation to purchase. And this we cannot follow, we cannot work this way because we don't have a way to escape from the inventory we would have purchased. I mean, there's not so much way to sell the parts. It's always turning into a closed loop. So the first thing you do, usually you challenge this by your own in-house solution. We tried, unfortunately, to trick with Excel. It has bring some satisfaction, I would say, some improvement in regards to what we had before. But using a normal distribution, reducing the data to one single number of one lead time as an average, as a median, one average customer demand per month, per week, per day, was not significant enough. And even we moved a step forward to a better customer satisfaction, wasn't what we expected. We still had, say, a lot of questions not answered, a lot of expectations which we were not able to to give a proper result with. Especially when we would like to see all options. You know, your CFO will ask you a supply chain, yeah, but what if? And this what if is costing you a lot of effort. You have to redo your own calculation, changing a business parameter and starting the work again and again and again. And we felt that the added value from supply chain practitioner or manager in the company was not really to spend time in statistics, to redo models to create this. Added value is more to somewhere define the business, to define the processes, to find the improvement we can bring to this, not losing time to create some mathematical models. So then we turn to one solution, which was a probabilistic forecasting. Among all the RFP we spent and the new setup we wanted to put in place, that was the one we were looking for. So we are looking for a partner which will have been able to somewhere do the maths and we do the business. I would say it was a bit challenging. And the only solution who could have answered this point was a solution based on the cloud computing. And that's what we implemented with our partner. The thing, we were not looking for a partner specialist in aviation supply chain, which is, I mean, like all your business has its own specificity. We literally train as CEO of this partnership company into aviation supply chain. And the result was very satisfactory. It went actually more than well. I say not more than expectation because we always expect the best, but was really, really fine. So on the next slide, I will start by the end. I will show you the results of this work we did with them, and then I will try to explain how we came to this work. So in percentage is availability on shelf we are benefiting, and the stock value for a certain definition of components. So the blue area represents all the possible inventory you can put in place to enter your customer demand or to create your inventory, basically. The market-leading solution, as you can see, was kind of far from the target. Our in-house solution has bring some kind of improvement, but the probabilistic forecasting has somewhere made a huge step to the optimum inventory we will have to set up. So we were not perfect. We started from, I would say, a level around 70% on shelf, meaning for the rest of the components, we have emergency cost to trigger, to answer the customer needs. Knowing that availability of competition is not that high in the aviation, especially on those aircraft we are supporting, because it's very small markets. A380, all in all, is less than 400 aircraft flying, and even in the future. So the OEMs and manufacturers are not really having overstocks on this kind of part. So it's on you to define correctly what you need to support your different aircraft. Thanks to this approach has not only been used, I'll say, in production, in daily service we give to our customers. It has as well been used, and now it's promoted by the sales department toward the customer when they do some answer to the RFP. It's really a tool they are using. It's used across the entire company. The finance is as well defining its budget based on this approach and this technology. And as I said, the sales is benefiting from this tool, which is able to answer really quickly to any change of business parameters. Is what if I'm adding a customer? What if I'm increasing the fleet size of an existing one? And all of this is answered in a really short time, and can give you an indication. It's now, for us, a 15-minute exercise to do this, which is resumed in basically 3 clicks. Rather than before, we have taken like 2 weeks to compute all those data and come back to the customer with an answer, which is, as you can imagine, not really satisfactory for winning a new customer. So how do we come to these results? The first thing we think that we ignored in the past, or we assume it was one constant data, is all the lead times of the supply chain. Instead of considering one average, one median lead time as one single number and applying or not a certain deviation, we can observe that the reality is far different from this. you can make all the improvements you expect, you can challenge the supplier on the best way, you will always have some cases that you didn't plan and that occurs. So either you get blind on this and you don't deliver your customer, or you try to somewhere simulate those cases as well, because this is where you miss the customer satisfaction. This is where you miss the 100% of completion of your service in the extreme cases. So the idea is to simulate all those lead times. This is the first exercise. The other issue when adding lead times is unfortunately not just an addition. It's a mathematical approach which is called convolution. I won't take time to explain this. It's not interesting for any one of you, but we can discuss this later. And that's a way, in fact, to keep this close to reality. That's what it's important, is that we don't start to move into a mathematical model which is going far from the reality. We'll always stick to what is actually happening. So based on this lead times we have defined, this horizon of probability, then we have to define the demand of the customers. So you can try to define, again, the demand with an average or with a median and say that tomorrow, next week, next month, the demand will have this shape or this quantity or this impact on your stock. I would say it's a bit of fantasy, because what is sure is that future is per definition uncertain. So giving a one single result for a future, you can yourself raise a question, why am I ignoring all the other possibilities? In this change of point of view, now that we have a probabilistic horizon, we measure the occurrence and the chance for each different demand level to occur. That's how we look at the demand. So we don't ignore any opportunity. If we look in this example, all those curves represent 100% of the demand chance, or the quantity of demand to occur within the probabilistic horizon we have defined earlier. So when I have those two elements in hand, now I have what I need to define my finance assets. How can I create my inventory? How should I talk to my CFO to define the budget I need to serve the customer in the frame we have to do? So to come to this, then again, the classic approach will be to define a safety stock, a one point of view, and my best stock level will be with a decimal. Start to be complicated to put half aircraft parts on shelf. Either I have it or I don't have it. And from your own feeling, from your experience, from your skills, you will decide to put this unit on top or not. And that you're not sure about the results, then you put a safety stock on top again. Then you're a bit far from what you expected at first. Your calculation for a certain service level has defined 3.6 units as an example, and you end with 6 parts. You don't already know why, but you do have 6 parts on shelf. Thanks to the probabilistic forecasting, we turn more the exercise into a what-if scenario. What if I have no parts on shelf? This is easy to answer. I have no service. But what if I have one part on shelf? And what if I put a second one and a third and fourth? So this is, say, an example on one part to make it visible. But the exercise somewhere is to create this vision for all the references you do have in your inventory. So this is working for our closed loop, but for sure it's as well working for the open loop. Like the production, the retails can as well use the same technology. Just the business parameters has to be a bit different in the inputs. And then we turn this, where we are used to have before replenishment and alert system, saying that this part is in danger, this part is in danger, into a complete and holistic overview of the investment we have to do, and even per priority. So if I'm saying this year I have $1 million to invest, I know which part are my top 150 items I need to invest to spend this $1 million. If I say I want to improve my service level by 5%, I know how much it costs. And I don't need to do a new exercise, a new simulation into this. I get directly an holistic vision of my service and my inventory. It's missing a word on the second one, but it's prioritized divestment. Is giving you the opportunity to free some stocks that you don't need anymore because life is changing, customers are changing, and it's turned a bit strange that now it's supply chain manager which are promoting to the finance saying, hey guys, I have cash to free in this inventory, I can get rid of it. Was not really the case before. Try to keep as much stock as you can to serve your customers. And in the same time, it allows us to really prioritize our issues because in terms of investment, when you know all those deviations we are observing in terms of lead times or customer demands, you can somewhere flag a responsibility behind this need of one more part. You'd say, this is a supply chain which is too long in these steps, has triggered an additional unit to be on shelf. So it's not only that you have to pay for everything, that you know where and why you do have to invest and increase your stock level. And what is important in this system is the accuracy of this system. Thanks to the alerts we have and the prioritization of our issues, we change a bit the role of the supply chain manager. Instead of being the one picking the parameters, non-stop keep tuning the tool, choosing the right model to be used, and somewhere working with the numbers itself, we change this role into someone which is really focused on the issues which are popping up to solving them, someone which is defining the business, the evolution, the changes he wants to do in his service, instead of somewhere focusing on something which is not adding any value to the customer, just somewhere losing his time doing this. And this machine learning that we are using with this tool, thanks to this, has allowed us to somewhere, I say at first, freeze the time of the operator, but as well to ensure a very good result and very good accuracy of the tool. And this accuracy is proved from day one thanks to the back testing. So not sure it's a correct English word. It's not that I'm going to test my back. It's more that I'm relying on the history of my data to be sure, and I rate all my models I'm using every time, so they have no rest. I mean, I don't choose a model. I don't choose a definition of a statistical model that is the best at this time, that will be the best for the future. This is not the case. Every day when we make our simulations, we test again all the models against each other, and we rate them. And the one which is showing the best stability, because for us this is what is important, for other business might be the nervosity of the tool that's having a better reaction, and then you can choose your model depending on your expectations, I would say. The resources which are required to do this are a bit different from what we can do, say, in-house, or what we should do in-house. Static computing, for doing this kind of job, somewhere we require to use only 5% of the hardware you will install. This will cost a lot of IT overhead, a lot of cost to maintain this thing. While on the cloud computing, the idea is really not to replicate what you can do in-house. It's really to use this power of the cloud to do something different. Cloud, you all know this in your private life for storing your pictures, your data, a volume. But the cloud is as well used and available with computation power, CPU, that you can rent for the volume you want, for the power you need. And what we were able to do before in 2 weeks, we do it now in 15 minutes. Because we dedicate the right amount of resources to our calculation. So now we do way more complex calculations than before, and in an infinite less time than what we were needed. So to summarize, this change is somewhere not impossible, but it's a change of logic, a change of approach in the optimization you do in your supply chain. And I would say, larger the scope you use this probabilistic forecasting, larger you challenge one parameter against each other, one product against each other. Choosing some of your drivers. For sure, they are first financial, but you get your customer satisfaction that can bring more activities. So it can be as well a parameter you want to consider. It's a change in the role of the people doing the supply chain, for sure. Because yeah, they won't have again the same the same activity, the same task to do, and we change from somewhere where you have to configure your software, you have to raise a question yourself, to a programmatic approach of the software, which is somewhere tuning itself to the results you need to do, and yeah, that's where you win a lot of time, and that's where you really focus on what you have to achieve. So I like to show this as a light in a dark room. Somewhere before, when we were using our one-time solution and 2 weeks to compute, it's like a candle in the room. You spot a small area. You have small lights on where can I make my inventory, but you don't know why. You don't know what is around you. Even if you improve a bit your way of doing with historical data, with own solution, you are still limited by number of spots you highlight in the room. Rather than with probabilistic forecasting, is like turning on the lights. You have suddenly an holistic overview of all the scenarios, all the what if, and I would say it's a bit confusing at first because then you have to decide. You have no longer an excuse to hide behind the forecasting. Yeah, but the forecast tell me to do this, so I did this and it doesn't work. With this approach, it's not true anymore. You can openly discuss, have a complete view of what will be your future results, and the accuracy of this is less than 1% error margin we are facing with since now 3 years we are fully using this tool. So it's really efficient and very accurate and saving a lot of money for us. So it's really for, I would say, a new foundation. So the picture might be a bit offensive, but supply chain has a lot of turn into methodologies to be applied, but even the new and latest advanced way of working are a lot of time basing their calculation, result computation on average, on median. At the stage to use the data, they are back to something which is very archaic. And thanks to the science bring into the supply chain with the probabilistic forecasting, we can bring a new foundation to all those methodologies. So it's not here to replace everything which is done. It's not here as the new thing to do. It's really a new base to do your thing better. And that the way we have implemented this, it has not allowed only to have good operations, it's as well supporting our growth. And the sales, as I said, is really promoting this tool, is really using this as a strength. And with the growth of all the data we'll have in supply chain, I mean, RFID, all of this is bringing more information into the system. As an example, an aircraft in less than 10 years will give every year 150 terabytes of data. So we can ignore this, or we can use this data as a competitive advantage and turn this with probabilistic forecasting that we can extend with more accuracy because we do have more data to lead you to the connected and efficient supply chain for 2030. So I'm done. Thank you.